it can be a little bit different. Here in Southern California, we have a lot more salt water in our coastal wetlands than freshwater. So we call these places salt marshes. Okay, and like you can see, I'm standing just outside the visitor center in one of the larger Southern California coastal salt marshes. All right. Now you might notice behind me that this area looks relatively flat, and you see some water in this tidal creek. Okay, well, first, you'll have to trust me, it's not very flat out here. There is some slope, there are deeper areas. I'm standing on the upper edge, and we are connected to the ocean. Okay, so if you've been to the ocean, you may experience that phenomenon where water comes really high and drains out really low, and we call those tides. And even though we're pretty far away from that connection where the river comes and meets the ocean and allows the salt water to fill this place up, we are influenced by the tide. And you're here with me today on a tide that's rising. So as we move through our program this morning, you may see the water fill even higher. Okay, so these are what we call dynamic systems. These salt marshes are dynamic. They're changing throughout the day. And in our part of the world, our salt marshes experience 2 high tides and 2 low tides a day. And you can imagine that might make it very challenging for species that live here. So we'll get into that in a little bit. Now, I want to share with you these the salt marsh plant community specifically, and talk a little bit about climate change. But let's get some background on climate change first. So before we go any further, so I'm going to share another image with you. Some of you may be familiar with exactly some of the reasons we are experiencing climate change. But I just want to a quick little background. And you think about the Earth and its atmosphere. And the atmosphere around the Earth is made up of water vapor. It's made up of gases like carbon dioxide and methane. And this atmosphere is important. We need it. It's you can think of it like a blanket, keeping our Earth warm. As the sun's energy comes in, these gases allow some of the sun's energy to stay in and keep us warm. But one thing that scientists have noticed and have been measuring is that there's been an increase of gases like carbon dioxide and methane from human activity in recent decades. This comes from burning fossil fuels like oil and gas that we need to heat our homes and move around the Earth, etc. And what this thickening blanket does is creates an overall warming of our planet, our land and our oceans, which then drives our weather patterns to be a lot more intense, a lot more extreme, okay, and contributes to this what we're experiencing, which we call climate change. Okay, so just a little background there I wanted to share with you. We want to assume everyone knows exactly what climate change, the causes of climate change are. Now, let's go back to the salt marsh and the plants that live here. Okay, and you see I'm surrounded by a lot of plants, and I am going to introduce you to a couple of them. But let's think about what plants, the salt marsh plants, what they have in common with other plants. And you might have to go back, depending on where you are in your education, back to that idea of photosynthesis. Maybe it's something you just recently learned, or maybe you're about to learn. But what is photosynthesis? It's a really cool process that plants have that ability to take carbon dioxide and sunlight and make their own food. Okay, they make their own food, they give off oxygen and create their own sugars. And that's what photosynthesis is. So it's very cool. So salt marsh plants, just like other plants, have that in common. Okay, but let's think about what might set them apart, living in this challenging dynamic system as the tide comes in, as the tide goes out. And this, remember, is really salty water. Almost the same salinity as the ocean, sometimes even a little bit higher, right? So I want to introduce my first plant with you. And it's a plant that's very close to where I'm standing, but I'm going to share it with you in an image, okay, just so we can get a little more close, get a little more into the detail of this species. Now, this is a fun plant to say. Maybe you've seen this before. Maybe some of you live near a salt marsh and are really familiar with all of this. This is a plant we call pickleweed, and it is one of the more common, easily grown, I guess, plants in the salt marsh. And you can see that it's not very tall. It's more succulent-like, and it's got a lot of red, and it's got a lot of green, and it kind of looks maybe a little bit like gummy worms, which is a common response that I get. And salt marsh plants, a lot of people think, like pickleweed, they think that maybe they are here because they need the salt water. They're plants that need salt water to live. And if any of you have experienced salt water in your own mouth, for example, as our bodies can't handle it, and you might assume that if you watered your own plants with salt water, that they probably wouldn't last very long, and that is the case. But in a salt marsh, the plants that live here, they don't need the salt water to live. They don't. In fact, they can equally be as harmed by salt water, okay? But they have something unique. They have an adaptation. Sometimes we refer to this as almost like a superpower, right? And a lot of people don't know by looking at them what's going on because it's happening inside. And in the case of pickleweed, now you can see in the left-hand bottom corner there, that inside a pickleweed leaf, and by the way, those little segments are leaves, it's just sort of stacked on top of each other, fused together. Inside those leaves are special cells. These specialized cells, they've evolved to have these areas, these pockets almost, whereas when salt water comes in, there's a place for that salt to go. And as long as that salt goes in those succulent specialized cells, the rest of the plant is unharmed. So pickleweed doesn't need that salt water. It just has an adaptation, a way, a kind of a trick in its tool belt, right, of how to deal with it, which is pretty amazing and allows plants to thrive in a very harsh environment with a very high salinity and a changing tide. So how many of you knew that? How many of you heard of pickleweed, seen pickleweed, and knew that? Pretty cool. And pickleweed's not the only plant that does that. It's a very dominant plant in our salt marsh. It's a lot of it are around me. And by the way, those red tips, they happen to be that are at the top of the plant, at the ends of the leaves. Those are the leaves that have contained the most salt, where the salt is most concentrated. And pickleweed eventually gets rid of the salt by dropping those tips off, by drying up and dropping those tips off. Pretty cool, just getting rid of it forever. So they hold on to it for a while and then they drop it off. And we call plants that do this, we call them accumulators. They're a lot like a succulent, except for it's salt water that they're storing. And they're doing it in that specialized way in order to be unharmed by salt. So that's pickleweed. There are other plants like it, but that's not the only adaptation here in the marsh. Now, I don't know if you can see behind me a little further out. And by the way, if I were to try to walk out to that water's edge, any guesses what might happen to me? This is a soggy, wet environment. It may look kind of lush and maybe dry when outside of the water, but it's not. The tide will actually reach bank to bank on the really high tides, and so it's pretty muddy. So I stay here up on the higher edge of the marsh. But if I were to walk out there, you might see behind me a plant that's blowing in the wind, a little taller than the rest of the salt marsh plant community, which again, by the way, as you can see, is not very tall, not very tall. And so I want to share an image of that plant with you, the one furthest out along the water's edge. And I'll do that again through another image. Let's see. And this is cordgrass. I want you to meet cordgrass. Cordgrass, one of the tallest plants in the salt marsh, growing maybe a little over 3 feet high out there. And by the way, these plants, they grow year after year. They're perennial plants. They have a growing season and they have a season where they die back. You are joining me now after a long growing season, and the plants are will start to go soon into a more dormant season. But cordgrass right now looking pretty healthy, pretty green, just like in this picture. And I wonder if some of you are reminded of another plant you might be more familiar with when you look at cordgrass. Maybe some of you are thinking cattails. Maybe some of you are thinking wheat. I've even heard lavender. These are plants that are tall, slender, and yes, like wheat, they're in the grass family. So cordgrass is in the grass family. You see those long, slender, flat, sword-like blades, which are the leaves. So think about what that might feel like. A lot like a blade of grass on a lawn. It's that flat feeling, thin and flat. No room for a succulent cell in there. So cordgrass has a different adaptation, a different adaptation for dealing with salt, because it has to deal with salt. So if it's not storing it in specialized cells and then accumulating and falling off later, it's doing something different, and it does something similar to what we do. When our bodies get really warm, we have an adaptation, almost like a superpower, something automatic that happens that cools us down, right? And that is you're probably guessing it, you're probably thinking about it. It was pretty warm earlier this week. I was doing a lot of it, and that's sweating, where water moves from the inside of your body to the outside of your body through our skin. Well, cordgrass and other plants with the same adaptation do something very similar. That salt water that they've taken up through their roots, moving through their stems and into those long, flat, blade-like leaves, gets excreted, like sweating. We call it excreted from the inside of the leaf to the outside of the leaf. And that, again, is salt water. So in that picture of the up close under a microscope look at a blade of cordgrass, what we're seeing there might look a lot like celery, but that's the blade of cordgrass. We're seeing the veins in the leaves. Did you know plants had veins? We can see the veins, and we can't see the pores, but what we can see is what is sort of left behind once the salt water is excreted on the outside. Just like when we sweat, our sweat dries up, salt water evaporates, and the water does, but the salt crystals in salt water get left behind. And under a microscope, this is what salt looks like on the outside of a cordgrass, of an excreter. Okay, you don't need the microscope to see it. You can see those shiny crystally salt crystals, without the microscope. But this is a pretty cool image of how it looks up close under a microscope. Excreters, getting rid of salt by pushing it out through their leaves. Right? Got to do something. So if you're a salt marsh plant, you're either an excreter or an accumulator. You can't be both. You have to be one, because otherwise you don't make it in this challenging environment known as a salt marsh. All right. So that's what salt marsh plants, that sort of sets them aside from other plants. They have that ability to deal with salt. But like all plants, again, they photosynthesize, okay? And remember, photosynthesis, taking carbon dioxide out of the atmosphere, converting it into sugar for itself, giving off oxygen. And so, plants are made up of carbon. A lot of our earth, living things on our earth made up of carbon. So let's look at some other plant communities. Okay, let's look at some other plant communities and think about how they might be similar, how they might be different. Because I guarantee not everyone lives near a salt marsh. In fact, salt marshes they're not as many of them as there used to be. But let me share with you another image, and let's look at some other plant communities. All right, let's see. So, and this image is more of a chart, a graph, a diagram, where we can see a few of the different communities, plant communities on our planet, and we're thinking about carbon. Okay, we're going to think about carbon, the material that makes up those plant communities. So some places, some plant communities, carbon, the plant stores carbon below the ground very well, and some plants have carbon above the ground. And we can see here that forests really show how much more carbon above the ground they have than other plant communities. You can see that. And why is that? Why do forests have more carbon above the ground? Well, if you think about a forest, right? Forests are made up of generally tall trees, right? So the trees, the stems, the branches, the trunks, the leaves, they're all pretty high above the ground. However, there is carbon below the ground through their root system. Other plant communities, some of them, like wetlands, you can see wetlands are one of the plant communities where there's not that much carbon above the ground. There's actually a lot more below the ground, okay? And I kind of hinted as to why that might be. How tall are wetlands? Not very tall. And I'll tell you, living in a salt marsh and having to deal with all that salt really takes a lot of energy. So the plants, although they do have a growing season, they don't grow quite as tall because they're really dealing with a lot of salt. And some plant communities have even less carbon above the ground. Okay, so I just really like that graph. So going back, let's go back to the heat trapping blanket, that atmosphere, and how it's important that we have gases in heat trapping gases in our atmosphere so that our planet isn't a cold one. So how does carbon before we noticed there was an increase in some of those gases, how does carbon get into the atmosphere naturally without human activity? Well, plants are made up of carbon, right? So how is that carbon in the plants released into the atmosphere? Well, if we go back to our forests, right? Forests are tall. They have a lot of carbon above ground, and they're subject to a few things. One is, and some of us may be a little more familiar with this than others, but there are wildfires that have occurred naturally for long, for history of the earth. And when a forest burns, that carbon above ground goes into the atmosphere, right? So forests burn naturally. They release some of that carbon into the atmosphere. And then also, on the forest floor, there's where those leaves fall. What's going on there? What's going on there? Those leaves live forever. We've got organisms that break down those leaves, are decomposers, right? The microorganisms breaking down that carbon and giving off carbon dioxide, methane, gases in that process of decomposition, right? Important. Decomposition is important. Those nutrients go back into the soil and provide life for those next generation of trees and plants. And so in forests, there's a lot of carbon that gets released through those natural processes. Let's think about a plant community that's not very tall, okay, but that might release a lot of green, heat trapping gases into the atmosphere. And I want to go back to thinking about grasslands, which maybe are sort of similar in height to a salt marsh. And maybe some of you live near a grassland and might be a little more familiar with this, but what are grasslands? What have they supported for many years and decades when it comes to, let's think of the food chain, right? Grasslands are places where we find our herbivores grazing, chewing, munching, digesting those plants, those grasses. So that carbon is being ingested, taken in, eaten by those herbivores, but what goes in comes out in different ways, right? These animals, when we breathe, we're giving off carbon dioxide, but also there's a process that happens when digestion occurs. Methane is produced, and methane is released when we burp, when we pass gas, and what herbivores do, right? So that is a natural process that puts that carbon dioxide and now methane into the atmosphere. And methane is a gas that doesn't often get talked about, but it is a heat trapping gas, and actually it's quite a bit more heat trapping than the carbon dioxide. But and so that's a big way that methane gets into the atmosphere. But like I said, we need those gases. And then let's see. And then decomposition. I said decomposition, grazing, and fire. Yeah, I covered the ways that naturally gets into the atmosphere. Now, as climate change has increased some of our weather patterns, and some of these events, these natural events, making them more intense, let's think about how salt marshes might release carbon dioxide or not release carbon dioxide or methane into the atmosphere. So if we go back to our forests that burn, right, then we see a lot of more intense wildfires now, but they're typically in, on land that's not wet. That's not a wetland. And like I mentioned, if I would quickly walk out here, I would get stuck and soggy. Salt marshes aren't susceptible to burning, right? They're not. They grow. They capture carbon. They grow, and they are made up of carbon, but they don't burn. They don't burn. So that sets them apart as far as how carbon gets into the atmosphere. What about grazing? Are they big grazers? Are there big grazers out here? One, any large grazers like me would get stuck walking out here. So you don't see large herbivores out here in salt marshes. Not a good habitat for them. They would get stuck. These plants are very salty. A lot of salt in these plants. Not very appetizing for even the small grazers. Right? So salt marshes don't really get grazed. Okay? So there aren't any animals, belching or passing gas after chewing on salt marsh plants. Okay? And then lastly, with decomposition, there is decomposition happening here. We have our decomposers, they're breaking down a lot of the dead plant material. However, one thing about salt marshes that's different than let's say a freshwater marsh, because if you have more rain and more bigger rivers creating your coastal salt marsh or your coastal marsh, it might be more fresh. But salt water has a property, an ability that actually traps any gases released that are naturally released through decomposition. Okay, so that's the salt marshes, unlike some of the in contrast to the other more freshwater or brackish marshes, do a better job at trapping decomposition, right? Keeping those under, keeping it from being released. So this process, and I'm going to share one of my favorite words with you guys. This process of taking in that carbon, right? Which is what all plants do. They take in carbon dioxide, and, they're storing it in different ways, depending on, and releasing it in different ways. But salt marsh plants, they take in that carbon and they hold it. And the word for that is sequester. I just love that word. And if you have someone, if you don't have anyone next, you don't have a neighbor, go ahead and say sequester. I just love that word. So salt marshes are awesome at sequestering carbon dioxide. Pull it out of the atmosphere, okay, and hold on to it through that. They don't burn, they aren't grazed, and salt water, traps those gases. And this happens can happen for thousands of years. They can sequester for like thousands of years that carbon dioxide, making them one of the better plant communities at helping with the fight of climate change, right? Fighting that climate change. Now, and we call these places that do this, we call them carbon sinks. So the carbon is really being sunk, right? And not getting re-released into the atmosphere, creating like a negative effect on the carbon in the atmosphere. Now, I mentioned that there's not a lot of these places left, right? Salt marshes are along these coastal environments. People like to live along the coast. They've been changed, they've been altered, they've become airports, they've become marinas, they've become parks, homes, right? So we don't have quite as many of them as we would like. Here at the Tijuana Estuary, we've been here since 1981, and part of a system of 29 research reserves that are dedicated at studying these coastal wetlands, including salt marshes. And here at the Tijuana Estuary, one of the things that we've been doing as part of that system is creating salt marsh habitat. We've been restoring salt marsh. In fact, this channel that I'm standing next to, which looks like it's getting a little more full, we're getting close to our high tide. It wasn't here when I started. And actually it was just newly created when I started in 1998. It's a restoration project where we created this area, 2 acres of salt marsh, to open up the tide in this area and provide more salt marsh habitat. It was the first phase in a larger project that we have going on here called the Tijuana Estuary Tidal Restoration Program, where we're hoping to, where we've restored an additional 20 and hope to restore a lot more. And one of the things that you can do is you can calculate, scientists can calculate how much carbon an area, an area of salt marsh can take in, okay? And so one of the fun things that we've done is to try to illustrate that for you, that if we could create all of the salt marsh that we want to here. And by the way, it's expensive to do, and that's why it doesn't happen a lot. One, you need you need the land, you need to find places where salt marshes were, or where they could be created new, and then you have to be able to pay for it. So let me share my last image with you, and that is, if Tijuana Estuary could restore the amount of salt marsh in addition to what we already have and what we've already restored, it would be like taking 113 Honda Civics off the road. So the amount of carbon dioxide 113 Honda Civics create in it, put out, emit in a year, if we could have the salt marsh that we want here, it would be like taking away 113 Honda Civics. Okay, now that kind of looks like a lot of Honda Civics to many of you. Maybe that is a lot of Honda Civics. 113, that's is that noticeable? It seems like a lot, but is that noticeable for those of you who are out there on the roads? Could you notice 113 less cars? Can the that's not maybe not, right? But it's something, and we're just one salt marsh. If you think about all the other salt marshes, could they make an impact on the fight against climate change? That's to be seen. So are salt marshes important in the fight against climate change? Right, we think so. Are they unique and have secret adaptations, living in a very challenging dynamic system like this? They sure are. And are they just like all the other plants? Most of the plants on our Earth, just doing what they do, pulling carbon out of the atmosphere. Nothing special than any other plant. Just grabbing that carbon dioxide to make their own food for survival. Yeah. So thank you all so much. Sorry about the little delay this morning, but I've been so happy and so excited to share this with you. And I guess a happy Climate Week. I hope that you're out there, have gotten some more awareness, visited some of our state parks. We have home learning programs and virtual programs throughout the state, not just for Climate Week, but for the year to come. So please join us again. We hope to see you. It's been a pleasure. My name is Marya. Thank you so much and have a great day.